Okay, let's start the session. So I will give you few of the problems related to the basic electrical circuits, and basic we will go through that. Whether the as the this quiz is there, quiz 2 for the NPTEL platform. So it has been taught that case series parallel combination different topologies, how to solve that. So let's move forward, and I will give you some of the problems. You will first try that whether you were able to solve that or not. Then after that, after a few minutes, I will solve myself, and you can see the process. And if you have any doubt, you can write in the chat box, or you can directly open your mic and ask me what could be the possible solutions for your questions and all. Okay. Here on the screen, there is a first a question is given. Try to solve that and let me know what is the correct answer for that. Ajit, you can close your mic. Huh? Ajit, please close your mic. If anyone get the answer, just let me know in the chat box that what is the correct answer. Or if you're having any doubt on that, also you can ask me. We will build up on that. First, we will see some of the problems from the uh, portal itself, and then we will try to solve that. Okay, and sure, there is a 8. I got one answer. Okay, let's other also do solve. And Devaki, please again verify whether it is a correct solution or not.
Sir, answer it. Eight.
Yeah, okay, let me check. Okay, let other also do solve, and after that, I will give the solution. Last 30 minutes, last 30 seconds to solve this problem. After that, we will move forward. Okay, let me give you the solution. uh, so in the problem, when you see, if you see the problem here, so it is written that all resistances are given in the are 1 ohm basically. So all resistances are equal in quantity, means quality basically. Then the value of I is given as a by 5. Okay, so if the value of I is given a by 5, you just have to solve that ki what is the current value, and then you can just divide it by 5, or you, if you get the answer in the divided by 5 terms, then you find it out what is the value of a. Okay, so there are two things we have seen either in the lecture, or if you have studied the basic electrical, then you have known that in 12 class 12 and 11th also we have that equation in the our physics. So series connection of the resistors and the series parallel equivalent. If you have a two resistances are in the series, suppose this is R1 and R2, so you have a R equivalent as a R1 plus R2. And if you have the two resistances are in the parallel, suppose this is the R1 and this is the R2. So R equivalent will be, it's a R1 R2 divided by R1 plus R2. Okay. How to verify whether the two elements are in the series or the parallel? So in the series connection, series connection mostly in the all the cases you have a one node common. Okay, suppose this is the R1 is there and the R2 is there. There is a shared node is there. This is the connection between the two elements. Okay, suppose this is node A, this is node B, this is node C. So you can see the node B is only common between the R1 and R2. But when you see here A and the node B. So this is node B. So this is also node B. So this is node A. So this is also node A. So the both R1 and R2 sharing the two nodes. Okay. So when you see two nodes which are there in the common point, so that is basically a scene that you can say they are in the parallel. Okay. If the single node is common, they are in the series. Okay, and this is basically, and in the series you already know the current will be equal across the both resistors, and potential will be the summation of both potential drops across the R1 and R2. But in the parallel you have a voltages will be the same in the, and the current will be divided, okay, based upon whatever the resistances are there. Okay, so here when you see this is also R and this is also R, this is also R. Okay, so this topology, when you figure it out, this one, this what I am highlighting, if you see there is a one node common here, one node common here. So if the two nodes are common here, so it means that they are in the parallel basically. Okay, so what are the basic sequence is there? So that if the two nodes are parallel, so there will be a R equivalent which is which can be calculated through the parallel sequence. Okay, so what will be the R equivalent? R multiplied by R divided by R plus R. That will come out to be 0.5 R. Okay. So R equivalent we have found it out that this parallel combination will be 0.R. And if you see this resistor and the other two other R equivalent which we have calculated, they have a one node common only. Okay. Other node is connected to some other resistor. Okay. It means that this whole circuit, this is like this. Okay, so here the one node is there, these are the A and B. So this resistor R and R, both nodes are common. Okay, so they are in the parallel. But when you see about this C node, they are actually in the not actually connected with the double point, they are connected with a single node here. Okay, so the R equivalent we found it out 0.5 R, that is connected with a series resistor. Okay, that is R. Okay, so overall it become 1.5 times of R. Okay, so this whole will become 1.5 R. But when you see that is same thing is connected in the parallel also. Okay, so 1.5 R, 1.5 R, 1.5 R is connected in parallel. So that will be divided by 2 only. Okay, so what it will become? It will become by 2 only, 0.75 R. How we have calculated? That is 1.5 R multiplied by 1.5 R divided by 3R. When you multiply here, it will become 2 and you will find out 0.75 R. Okay. So this whole circuit we have find it out with 1 is here also. So the whole will become 1.75 R. Okay. but that is same thing which is connected in the parallel also. So that only thing you have, what you have to do is you just have to divide it by 2. What it will become? Point 3 6 2 7 14 and 5 10 0.375. So here the also the one resistor is given, so it's overall it become 1.375. When you divide it, find it out what is the current. Current is basically the voltage divided by R equivalent. What is the voltage? 3. R equivalent is 1.375. When you find it out, I think, let me check. 3 divided by 1.375. It is coming 24 by 11. Okay. Okay. Let me check again. R zero point 0.5 R, point 1.5 R, 1.5 0.75 R, 0.75 1.75 R, 1.75 divided by 2, 7 by 8 R plus 1, 3 divided by answer. Okay, so it will come out to be 8 by 5. Okay, I have made some mistake. I think you can check from your side. It will come out to be A is equal to 8 only. Okay, it is coming till this. Overall equivalent is coming this with the summation of A is a 8 by 5. Okay, so the overall answer will come out to be 8. Okay, any doubt in this? If you have any doubt, just try to learn from there, and if you have any doubt, just let me know either in the chat box, or you can open your mic and ask me. Okay, either you have in doubt in the series and parallel combination or any kind of thing, you just let me know. Any doubt?
No, sir, everything clear.
Okay, okay. So, based upon your feedback, so let's move forward to the other kind of problem. So, try to solve this. This is also related to that R equivalents only. You have to find out what is the value of I1 which is flowing through here. Okay. Reduce the network. If you know the series and parallel combination, just you have to reduce the network and find it out what is the value of current. Current is basically voltage divided by R equivalent. Try to solve this.
One 1.5.
Okay, so write in the chat box the same value what you have got. Let other also do solve.
Sir, 1.5.
1.5 milliampere.
Okay, okay. Write in the chat box whatever you got, so that others can see and verify whether their results are correct or not. And you should also verify whether it is correct or not. We will solve that and check whether it's coming the same or not. Take your time to solve. There is no hurry in that. Okay. Okay, I got multiple answers as a 1.5 milliamps. Okay. Okay, whoever solved and who have not solved, just listen here. So, if you see the networks, basic, whatever the topology is there, you just have to observe certain things, that what kind of reductions are possible in that circuit. Okay, either series combination, either parallel combination, or multiple combination can be possible, or star delta convergence there. So you just have to always try to reduce the network, so that make easy to solve the current voltages and different possibilities. So if you see this network, it if you see this network, so there is a resistor here connected, and there is a one resistor connected here. If you observe this, there is a two nodes which are connected. Okay, suppose I consider this as a node A, this is node B. So if you can see the two nodes are common in that. Okay, so they are in the parallel. Okay, so when you see this whole network with this resistor, so there is a one node is common. Okay, so in this network there is a one node is common. Okay, only one node. So what they are in the series. Okay, let's reduce that. Okay, when you reduce, this is the 1.2. Let me erase this. So you have, this is the 12 ohm and this is the 8 ohm. Okay, this is the 12 multiply, what will be the R equivalent? R equivalent will be the 12 multiplied by 8 divided by 12 plus 8, that is 20, plus 7.2. Okay, when you solve, how what it will come, 10 6 8 4.8 plus 7.2, I think. Okay, 96 divided by 20, it's basically 4.8, that is 7.5, 11, 12. Okay, so the 12 ohm which we have got from this are equivalent. Okay, now you see this 6 kilo ohm, kilo ohm, this kilo ohm, say 12 kilo ohm, and this 6 kilo ohm are in the parallel. So what here, this is 12 kilo ohm and this is the 6 kilo ohm. When you try to solve, they are in the parallel basically. Okay, let me add. Okay, so let's what will be the R equivalent then? 12 multiplied by 6 divided by 18. Okay, so it will be 3 4 kilo ohms. Okay, what will be the current which is flowing from the source side basically? So it will enter here, then get bifurcated based upon the resistance, then again move forward and then get bifurcated. Okay, I will be equal to 6 volt, whatever the voltage source is there. R equivalent, what is the R equivalent? Basically 6 by 4 kilo ohms. Okay, and this is the volt. Okay, so it will come out to be 1.5 milliamps. Okay, so you don't have to scared by seeing the topology, it will get reduced. Okay, what because uh, it's a optional basically, what kind of options will be correct, A B C D. So the network will always will get reduced. Okay, either through the series combination or the parallel combination or the combination of combinations. Okay, let's move forward in this same series, try to solve this. Last 1 minute. Okay, I got one answer as 1.125. Re-verify whether it is correct or not. Okay, one other answer 2.3 milliamps. Okay, both students should verify whether their answers are correct or not. I will demonstrate a simple rule to solve this kind of problem. Okay, you will never forget. Okay, 0.125, three different answers. Okay, other answer also 0.175 negative also. Okay, let me give the solution. Okay, so in this kind of problem, listen here. Stop solving. So if you see the topology here, there are different elements are connected here. First, the important point to see that sources and other elements like loads. I mean to say ki R, L, C, these kind of combinations. Okay, and it inside components as well, like some resistors are connected here. Okay, sources are of two types. One is the dependent source, other is the independent sources. Okay, suppose I consider a battery which supplies a current and it is supplying through some R load. Okay, so you can say that ki this is not dependent on anything. So if it is a 5 volt, so it is supplying through their 5 volt only. It is not dependent upon any of the parameters. Okay, they are called as independent sources. Some are the dependent sources. Suppose here in the example itself, question itself, it is written 4 Vx. Okay, so this is a voltage source by default. This is a potential is there, so this is a voltage source. Okay, how it is being controlled? It is controlled through a voltages only. Okay, so this is called as a voltage dependent voltage source. Okay, this is a voltage dependent voltage source. Okay, so this is the voltage dependent voltage source. Okay, if it is controlled by some current, suppose it is written 4ix, so it means that current dependent voltage source. If it is a current source and dependent upon a current, so current dependent current source or current dependent voltage source. Okay, so these are the different combinations which are possible in the source side. Okay, so in this important problem is that how to solve this network when you have a dependent sources into the figures. Okay, so to solve this kind of topologies, you just have to master in the KCL and the KVL. Basic, basic KCL and the basic KVL. Okay, what KCL says? Summation of I net is equal to 0 at a particular node. What is KVL? Summation of V net is 0 at in a particular branch. Okay, suppose if you see this circuit here, suppose I consider this node I consider as a Okay, let's zoom it. If you see this node, it is connected to three branches. Okay, this is the one, this is the second, and this is connected to the voltage source. Okay, this is like this, and it is connected to a voltage source. Okay, so is this node is very important. Take a node and apply KCL there. Okay, suppose I consider this node as a okay, and I apply a KCL at here, so it means that whatever the current is coming here, net will be equal to 0. Okay, what I do usually in from my perspective, I always consider the current to leaving the node. Okay, I always consider that. If it is an incoming current, so I take it as a opposite minus. Okay, suppose in this topology, if you see in the topology, it is basically written as current is coming into the node. Okay, so what I will consider? I will consider as a minus I1. Okay, plus And also you have to consider one as a reference node. Okay, what whichever node you want to consider as a reference node, you can consider that, and it is at a and grounded, it will be at a zero potential. Okay, so I usually consider the node which is the farthest and which is easy to solve. Okay, suppose this is node is connected to all the branches, so if I consider it at a 0 volt, so it will be easy to solve. Okay, what amount of current is going in this branch? Okay, it will be like this. Suppose I consider this as a voltage V. Okay, so this whole branch voltage, this is the 12 volt. Okay, if it is a grounded 0 volt, so other potential here also it is a 12 volt, and at this node, at node A, it will be 12 volt. Here also it will be a 12 volt only. Okay, why? Because it is connected at a same potential. Okay, this is considered as a same potential. If I am considering as a 0, so the other side will become 12 volt. Okay, so what is the voltage as here at a node A? It's a 12 volt. So what amount of current is going out of this branch? This branch, it is basically 12 minus 0, because the downward side it's a 0 potential. What is the resistance overall? It is a 24 kilo ohms. Okay, plus what about the current which is going into the other branch? What is the current? It will be basically the voltage difference divided by resistor. What is the voltage? 12 minus 4 times of Vx divided by 6.4 kilo ohms. Okay, 6.4 kilo ohms. Okay, so this is the one equation which we have got. What about the variables? If you see, the variables are two in this. Yeah, you can ask Shivam. What do you wanted to ask?
Sir, where comes minus I1?
Yeah,
Because I think it is plus.
no, no, no. Actually, what I consider usually, suppose I take this branch. Suppose I'm considering here, I am applying KCL here. Okay. What I usually do, that I always consider the current to be outgoing of that node. Okay, if it is certain current which is incoming, I consider it as a negative. So what is the basic definition? That whatever the current incoming will be current outgoing. Okay, so what I will do, minus I out is equal to 0. This is the only thing I do, that whatever the current which is going out of the network, node it consider as a positive. If it is coming into the node, I consider it as a negative. So its whole summation became 0. Okay,
Yes,
getting my
sir.
point? Okay,
Yes, sir. I understand totally.
okay. So here, if you see the equation, basically there are two variables. Variables, what are the variables? I1 and the Vx. So it means that you need a second equation also to solve the two variables. Okay. Let's see what is the other thing we can see here. Here the Vx value is given. Okay, Vx value is given here as a voltage is given across the 8 kilo ohm. Okay, so in the some situation we can find it out, what could be the possible current flowing through it. Okay, or you can say like this also, that 12 minus Vx, what is the voltage across which is coming here? Suppose this is negative is connected to ground, so this potential will become Vx only. Okay, so 12 minus Vx divided by 16 kilo ohm, that will be the same current will flow through the Vx by 8 kilo ohm. Are you getting my point? Okay, so because it's a series branch and the voltage is given here, the Vx. Okay, I know what is the current to be flown. Okay, so the current which will flow here is the 12 divided by total resistance. Okay, it's basically this one only. Okay, it's a zero point 0.5 milliamps which will flow. What will be the potential Vx? Vx is basically I times of R. What is the I? I is the zero point 0.5 milliamps multiplied by R, 8 kilo ohm. So it will become 4 volt. Getting my point? Because the current which is flowing through the 16 kilo ohm will be the same as whatever the current flowing here as well. Okay, I just applied that whatever the current is flowing from that side will come to the lower side itself. Okay, so what we found it that Vx value is equal to 4 volt. Okay, If it is a 4 volt, let's solve it. Minus I1, I consider is at a zero point 0.5 milliamps plus, this is the 4 volt. 4 4 16 minus 4 divided by 6.4, okay, milliamps is equal to 0. Let's solve it. 4 divided by 6.4, and it's in the minus, plus 4.5, okay, it will come out to be plus I1 is equal to 0.125 milliamps, okay. Why that I'm considering here as a negative sign? It will be always easy to solve. Follow a single convention and try to apply in the all the figures whatever the topology you get, okay. Simple rule, or consider all current going out of that node as a positive, whatever comes into the node just consider as a negative. And if it is a dependent source is there, so you must have a single equation which will be defined by that, okay, because there will be extra variable come into the equation side, okay. So there should be something inside of the network that will potentially lead to solve the that dependent value, okay. Here the same current topology, when this current will flow from here to here, I just apply that whatever the potential is there, suppose this is like this only, I consider A, B, C. So what I applied that, this is suppose IR1 and R2. VA minus VB by R1 is equal to VB minus VC divided by R2. That same current will flow there through the network. That is series combination. Okay. Any doubt in this? I will upload the slide. You try to solve by yourself again, and then you will realize. Any
Sorry,
doubt?
bit clear.
Uh, I'm not able to understand. Can you repeat, please?
Everything is clear, sir. Move ahead.
Okay, okay, that is fine. So there is a doubt in the chat box. Ideally, what should be done with the internal resistance of a controlled source? Okay, that question will come into the further slide. I will explain that. I'm ideally I am also having in the mind that I should explain that if with the internal resistances are there of a particular source. Okay. Uh, Let me explain here itself. Suppose there is a ideally can be a voltage source or a current source will be there, okay. So usually a resistor which come into the picture with a voltage source, they are in the series, and whatever the current resistor come into the with the internal resistance basically of a source, that is current source, they are in the parallel, okay. In the ideal circuit, this in the voltage source R is 0, and in the ideal current source R is equal to infinite. Well, it means that it will be open circuited here and it is sorted here, okay. So if it is a written that in the question that it's an ideal source, okay, or any not anything written, okay, so then you should consider always that it is a ideal source, unless and until it is written that it's a practical source or it's a non-ideal source. And if it is written, then they will provide a value of their internal resistances like 2 ohm, 3 ohm, or any value that will be always specified in the question. It will be not like that ki they will make a open loop that you should consider a certain value. Okay. If it is a non-ideal behavior, then it will be written in the problem and the value will be given. Okay. Any doubt again? Others, please try to solve this problem. Satyendra, any doubt further?
Sir,
Yes.
sir, what's the difference between the circle notation and diamond notation in the current source?
Yes, that is basically circular when we say that this is basically a independent source. Okay. And when we show about this diamond notation, they are basically a controlled source. If here when you see here, it's a dependent. This current is dependent upon a certain voltage. So I is basically a function of certain voltage. Okay. So this is basically to show that to differentiate between a dependent source and a independent source. So whenever you see a diamond layer, so this is basically a dependent source. Either it will be dependent upon the current, or it will be dependent upon a certain voltage. Here it is dependent upon the voltage. Okay.
Okay, sir. Thank you.
Yeah. Yes. Satyan is asking that whatever I have explained in the ideal source, whether it is dependent source, it is applicable to the dependent source as well. Yes. Dependent sources may be having some ideal non-ideality into the picture, so that will be also specified, because it's a source only but depending upon something else. Okay, so then it will be like that ki it is source only, so it may have some internal resistance into the picture. Okay, so then is it clear? Okay. Okay, try to solve this problem. Assume the same thing what I have told, that ki summation of I net is 0. Here also it is applicable.
Hello, sir. If I directly multiply 2K and 4 milliampere, I get Vx value.
Okay, write in the chat box whatever you got. I will verify. It's a very easy problem. Just you have to go through the method which I have told. Last 1 minute. Okay, 10.9 volt, 1.5 milliamps. Voltage is being asked, Nilesh. 7.9 volt. Okay, 20 volt. There are different answers are coming. Okay. Ooh. Okay, let me solve. Listen here. Stop solving. Just listen here. I will repeat the concept which I have told in the last problem. So let's take this node as a our node where we will apply the KCL. Okay, KCL is basically I net will be 0. For that we need a reference. Suppose I take this as a reference. This is as a 0 volt. Okay, whichever node you want, you can take the as a reference node. Okay, so if you see here at a node A, the current is coming, some current is coming here. Okay, it's a 4 milliamps. Okay, and other is connected like this. So this is basically the Vx here. There is a resistor connected, and there is a one resistor connected here is the 4 kilo ohms. Okay, and other there is a current source which is going out of that node. Okay, so if you wanted to write a KCL equation here, so how it will look like? It will be minus 4 milliamps. Why? It is coming into the node. What is the current going out of that node? Because it's a voltage is given. This is the V1. Okay. So if the negative is connected to the ground, 0 volt, so the whole voltage will appear here. This is the V1. So that will be similar to the voltage which is there at a node. Okay. So what is the current which will flow? That is V1 minus 0 divided by the overall resistor. How much it is? 6 kilo ohms. Plus this current, when you see it is going out of that node, it is what its value, it's a zero point 0.6 Vx. Okay, is equal to 0. Okay, so when you see here, there is a two variables are given. Okay, this is the V1 is one variable, Vx is second variable. So we need is another equation to solve this. Okay, how to find it out? Okay, so when you see 4 milliamps which is coming here, and this zero point 0.6 Vx, zero point 0.6 Vx which is going here, so some current will flow here as well. Okay, so the Vx will become 4 coming here, zero point 0.6 going here, so it will be basically 4 minus zero point 0.6 Vx. Okay, so the Vx is equal to basically 4 minus zero point 0.6 Vx multiplied by what is the current, that is 2 resistor which is there at a 2. Okay, 2 kilo ohm. Okay, so Vx is equal to 8 minus 1.2 times of Vx. Okay, if you want to solve, it will come out at 2.2 times of Vx is equal to 8. So Vx value you can get. Okay, let me solve that. So Vx value come out to be 8 divided by 2.2. That will come out to be 3.63. It will come out to be 3.63 volt. Okay, so we have got the value of the Vx. So this is the first equation what we have got. So if we put this value Vx value here, we will get the value of the V1. Okay, so let's solve. Minus 4 plus V1 by 6, it will come into the millivolt, plus zero point 0.6 times of 3.63. Okay, this 4 was there, 4 was in there the milli ohms, and 2 was there in the kilo ohms, so that's why it will become like this. Okay, is equal to 0, and 6 in the kilo ohm, so that's why it will be basically in the volt only. How much it will come? Zero point 0.6 multiplied by 3.63 minus 4, it will come out to be multiplied by 6, so it will come out to be 10.9, I think. Let's solve again for the verification. 4 minus zero point 0.6 times of Vx. So whatever the current, 4 minus zero point 0.6 times of Vx, uh, it will be basically the current multiplied by 2. So it will be Vx, 4 minus 4 to the 8 minus 1.2, 2.2 Vx is equal to 8. 8 divided by 2.2, it will come out to be 3.63. And then we have kept into the equation multiplied by zero point 0.6 minus 4 multiplied by 6, it will come out to be 10.9. Okay, nearly equal to 11 volt. Okay, so this is
Sir,
the, yes, tell me.
sir, how to find the value of Vx, sir? It is just a little confusion.
Yes, it is confusing because For solving these kind of problems, it is required lot of practice. So when you solve the multiple types of problem, multiple times the problem, then you will get the feel that by looking into the network you can get the whatever the solution is being required for that problem. It will come by practice. Suppose you take this problem, you solve it 2 3 times, then again if I give a certain little bit changed variable and different topology and similar kind of problem, you will be able to see by a first glance that this should be the method to solve this kind of problem. Okay, so basic thumb rule in the network, this electrical basic electrical circuit is the practice. However number of questions you will solve, you will get the iterations, means a lot of problems when you solve multiple times, then you will get the feel of that networks. Okay, because here when we are solving and applying this KCL at a particular node, we got the two variables. When it comes in by default, in my mind came that I need two equations to solve the two variables. Then my mind should go that where should I find the second equation so that I can put in the first equation to solve that. Okay, then just figure it out in the network itself how to solve that. Then my mind go into that that current will be going into the network and the both currents are given, so I just subtract and get the branch current of that. Okay, so that's why I have applied that v is equal to IR, so Vx is equal to current which is flowing through that resistor multiplied by the resistance value, I can get the value of the Vx. Okay, that is by default. When you solve the multiple problems you can get that. Okay, every time when
Okay,
you,
sir. Thank you, sir.
yes, every time when you see the two variables, just it should click in your mind that there should be a different equation which will be able to solve this first equation. Okay, let's move further, try to solve this problem. Let me take the charger.
Sir, the value of V is, what is the value of V, sir?
What is the value of V? What you are asking, the value of V or the Vx?
Voltage, sir. Value of V. V.
V is the voltage of this independent source and the Vx is the voltage across this current source, this dependent current source. And this dependent current source value is the 3 times of Ix. And there is a one more dependent current source which is dependent upon the voltage whose value is the 0.625 millisiemens Vx.
Sir, whether the answer is expected in terms of V.
Okay, whatever the answer is coming, if you're not able to find out the exact absolute value, you can write in the give in the dependent form as well. I have not solved that questions yet, so I will be solving with you only.
I think it comes out to minus 1.25 milli V.
Millivolt, like this.
Mm,
V.
I,
V. V. V is the voltage source. V.
Okay, okay.
Magnitude of voltage source.
Write in the chat box. Write in the chat box.
I
One
am
pointed
I
sign.
am find sir another answer 2.5.
Okay, let me solve them. Let me solve them to check whether okay there are different answers are coming. Okay, let me solve. Let me check whether which a value will come. So when I see the topology, there is a different things are there. Very confusing. Suppose I draw it little bit further. Okay, this is like this. Circuit is like this. I'm not writing value. Just see the network. Okay, how it is there. So if you see the network, how it is there, it's a voltage source is there, which is connected to a current source and dependent current source basically, and other is also connected with the dependent current source only. Okay, and its value is given V, and across this current source, the value is given Vx, the voltage across this current source, and what is the value of this? This is the 3Ix. And one more dependent current source is there, which value is the 0.625 millisiemens Vx. And there is a current because it's dependent upon the Vx, so Vx value is already given here. And also is dependent upon certain current because this current source is dependent upon the Ix, so Ix is given here. Okay. So after seeing the topology, it seems to be very complicated that number of variables are more. Okay, let's go step by step. What I am assuming that there is a parallel. They all are connected in the parallel. Okay, and this is the node which we will consider for solving this. Okay, so this will be the grounded. Okay, this is at the zero potential. First glimpse that I both are in the parallel, so V is equal to the Vx. Okay, first equation. Let's solve through the KVL. So here the current is given I1 minus I1 is coming into the system plus what is the current coming here? It's also coming in into the network, so that will be minus 3Ix. Okay, and the other is the current. When you see there are two currents are given. Here is the Ix is given and there is a other current is also given. So in a branch the current will be constant value, it should not be variable. So it means that Ix is equal to minus times of 0.625 Vx. Okay, so this will be a second equation. Okay, because it's in the branch only. So when you see here, so let me point it out. Suppose you see this branch. Okay, so in the same branch here, not in the loop, in the branch itself, the current flowing, when you see here, Ix is equal to minus times of 0.625 Vx. Okay, let's what we are solving, the applying the KCL here. Okay, minus I1 minus 3Ix plus, when you see minus Ix is also coming into the node itself. Okay, so when I see this, so
Sir, explain repeatedly. Ix is equal to minus 0.625 Vx.
okay, let me explain again. So when you see this, so this is the one current source is given like this, 0.625 millisiemens Vx, and there is a branch current is given here, that is the Ix. Okay, so what we have learned that ki if it this is a same branch. Okay, if it is a same branch connected, both are in connected, there is no other parallel sources are there, so they are in the series. So series means the current will be basically the same, and this branch is same, so the branch current is constant, means ki it should not be variable. So it means that this current will be equal to this current only. Okay, but their directions are very different. One is the incoming, one is the outgoing, so that's why we have taken as a negative sign. But when you see the in the
Yes, sir.
absolute,
वो
got the point?
yes, sir.
Okay, So, but if you see in the magnitude terms, both value will be equal. Only change the convention, I have taken this as a negative because other is flowing in the different direction only. Okay. Let's focus on the third equation. So here, when you see here, it is given the IL I1 is equal to minus 4 times of Ix will come out to be in the equation. So here, when you see, there is a three variables are there. I think three variables I1, Vx, Ix. Three variables are there and three equations are given. Okay, let's put in somewhere. And also there is a one V is also there. So there is a four variable V is also there. Okay, let's put the value of Ix. I think it is like this only. So I1 is equal to 4 times of Ix minus 4 times of Ix. I1 is equal to minus 462.5 Vx. 4 times of 0.625, it will come out to be 6.4 times of Vx. Okay, I think it's required in the Vx term only. So I think 4 times of Ix is 0.625 and 0.625 multiplied by 4, that is 2.5. Sorry. So it's a point 2.5 times of Vx. Okay. So I think V in the Vx terms only the results is being required. Okay. So it is coming into the I1 is equal to 2.5 times of Vx because there is a four variables and there is a three equations possible which I can see from here. And to solve this, we need a certain fourth equation to for the four variables.
Sir, we can save there is parallel, so V is equal to Vx.
Yes. Yes, V is equal to Vx. We have already taken. This is the one first equation which we have seen. Getting my point? Okay.
Sir,
So
everything is clear.
yeah, so I think it's required in the Vx term only. I've taken from the this example questions which is given on the NPTEL only. So maybe the part they have asked that ki I1 by Vx value or I1 is equal to x times of Vx. So what is the value of the x? So in that form, maybe may it have been asked. Okay. So this is the overall thing that we have to find it out the number of equations, whatever the number of variables are there. Okay, it's a just a observation based problem which will come through the practice only. Okay, let's move forward. Try to solve this problem.
So I'm having a doubt in the previous problem.
Yes, tell me.
If we write down KCL at point A, let us say,
Mm-hmm.
then I1 plus 3 times Ix
Mm-hmm.
minus 0.625
Mm-hmm.
milli Vx
Ah,
equal to 0.
okay.
Is this equation okay?
Yeah, this is equation okay because that is the same thing. If you put this ix value here, that will come out to
Mhm.
be same equation only. Okay, I just make it as a separate equation. If you put the value of ix, you will get the same equation only. Okay.
Okay.
Okay, let's
So,
move further. Try to solve this. Mm-hmm. Okay.
Sir, 2.5 milliampere.
Okay, write in the chat box so I can verify after solving. Okay. Okay, let me solve this problem. So I think more or less everyone is getting similar answers. So let's solve. Solve for the same thing. So here, important point is that the KVL is being required. So to solve this kind of problem, what usually I do, I move to the branch and try to pick the first voltage which is there. Okay, let me explain further. Suppose there is a three voltage sources are there and there is a cold closed loop. There is a this voltage, this voltage here is given. Okay, V1, V2, V3, V4, and some load is connected. Okay, so if I move through this loop, suppose this loop is there, so I just move through the one negative terminal I considered. So suppose this will be minus V1 and then move to the second source, it is positive, so plus V2, then third source plus V3, other source minus V4. You can go in the negative direction also. So like this I calculate the KVL. Okay, this is similar concept. You can take the positive also, but take the all the positives. Okay, or is the second potential only. Okay, so it's a simple rule to solve the multiple KVL equations. There in the KCL, what I have told, always consider the voltage to be, always consider the current to be flowing out of that network. Okay, whenever you see that current is incoming to the node network, so you should take the negative. Okay, similarly, let's move in this. Okay, suppose this is a loop only, one loop. So let's write the KVL. Okay, summation of V is equal to 0 minus times of 12 plus times of 3 times of Vx plus times of 4 times of Vx. Why? Because I am considering the first potential. So I move like this. So I take the first negative. So I consider minus 5, minus 12. Then I move to the second source. Here the positive is given. So I take the plus 3Vx. Then I move to the other load or source, whatever is there. So I take it as a positive because it's a connected first potential I am considering. Okay. For solving this equation, you get a 4Vx is equal to 12. So Vx will come out to be 3 volt. Okay. So it is asking what is the value of I1. I1 is basically equal to Vx is equal to I1 times of 1.2 kilo ohms. Why? Because I need a second equation to solve for the I1 because the Vx I have calculated, but there is a no variable inside of that of I1. Okay. So, but I know that ki whatever the current will flow from the 12 volt will go into the 3Vx, same current will flow through the resistor also. Okay. So, if it flows through the resistor also, it means that the same current will be there. So, Vx we have found it out 3. So, I1 multiplied by 1.2 kilo ohms. Okay. So what will be the value of I1? I1 is equal to 3 divided by 1.2 milliamps. That will come out to be 30 here, 4, 3, 4, 3, 10, 2.5 milliamps. Okay. So here the simple rule, KVL apply, but apply through some method which you take always as a constant for your study, whole study. Okay, don't change your rules. Okay, so it will be make your things very easy. Always I will consider whatever the first potential will come, always I will consider. Okay, and move forward in the loop and write the KVL equation. Okay, any doubt in this? Okay, then let's move further to the other question. Try to solve this.
What's I need to find, sir, in this
Question
question?
question is that you have to find out the value of R here.
ಹೌದಾ ಅವ್ರದ್ದೆಲ್ಲ ಖಾಲಿ ಆಗಿತ್ತಂತ ನನ್ನ ಕಡೆ ಕ್ಯಾಶ್ ಐತೆ ನನ್ನ ಫೋನ್ ಇಲ್ಲಲ್ಲ ಅಮೌಂಟ್ ಐತೆ ಕ್ಯಾಶ್ ಫೋನ್ಪೇದಾಗ ನನ್ನ ಫೋನ್ಪೇ ಇಲ್ಲಲ್ಲ ಅದಕ್ಕೆ ಯಾರ ಕಡೆ ರೆಡಿ ನೋಡ್ತೇನೆ ಅವ್ರಿಗೆ ರೀಚಾರ್ಜ್ ಆಗ್ತದೆ ನನ್ನ ಕಡೆ ಫೋನ್ಪೇದಾಗ ಕ್ಯಾಶ್ ಐತಿ ಆದ್ರೆ ನನ್ನ ಫೋನ್ ಹಾಳಾಗೈತಲ್ಲ ಇದ್ರೊಳಗೆ ಅದು ಫೋನ್ಪೇ ಆಗಾತಿಲ್ಲ ಹಾಕೊಳ್ಳಿ ನಂಬರ್ ಮಮ್ಮಿದು ಇಲ್ಲಲ್ಲ ಮಮ್ಮಿದು
Please close your mic. Whoever is talking on the call.
ಈಗ ಅರ್ಜೆಂಟ್ ಬೇಕಾ ಆನ್ಲೈನ್ ಐತೆ ಅದಕ್ಕೆ ಇನ್ನೊಂದು ಅರ್ಧ ತಾಸು ತಗೋಬೇಕು
This will be the last problem of the today's session. So I will give you some of the problems which you will solve by yourself and we will discuss in the next tutorial session. But try to solve this problem after that I will.
Sir, 12 ohm.
Write in the chat box, we will check that. Verify again whether it is correct or not. Okay, let me give the solution for this. Uh, 12, okay, okay, and 12 ohm, okay. Let me solve this. Listen here, everyone. So this problem is basically the actually the some advanced version of the whatever we have seen in the previous questions. Here just you have to make some observations. Observations means while solving the KCL, what we were doing, we were grounding one node. We were doing the grounding a node which will come at a zero potential. Okay, 0 volt. So here also when you see the observation, if I consider this as a 0 volt, in the similar manner, so this negative will go into the 0 volt. So the other voltage will come. Suppose here I consider a node, so this will come out to be 12 volt. Okay. Similarly, this voltage, this node also will become 12 volt. Okay. Now when you see here, the opposite side here, that this will also become the 0 volt and this node will become 40 volt. Getting my point? So what is asking? It is asking that what is the register across that. Okay. So when you take this branch, if you have a node like this, okay, and this is a potential VA and VB, and this is R. So what is the current which flow here? VA minus VB is equal to I times of R. Okay. So similarly, here the 12, the 100 volt. Sorry, this is a 100 volt. 100 volt, 100 minus 40 is equal to I times of R. Okay, this is the first equation which we have got. But we having a I as a variable. Okay, now we have to need the second equation. Apply the KCL here. When you apply KCL here, so suppose I consider it as a voltage V. Okay, so what will be the value here? So it will be basically I consider that current is going out of that network. So if I consider voltage here, so it will be like this: V minus 100 divided by 14. Please close your mic here. Okay, so this is basically the V minus 100 by 14 plus V by 2, because I considering that current is going out of this node, and the other current which is going here, it is like this, that plus V minus 40 by 1 ohm is equal to 0. Okay, this is the one observation which I can see. One another observation I can also see, from here we can get the value of the voltage. Okay, if we get the voltage here, the V, through that we can find it out what is the current which is coming here. Okay, if you get the voltage from here, if you solve, you will get the value of the voltage. After that you can see what the current is coming here, because it's just a V minus 100 by 14 volt. Okay, so node will be like this. You will be knowing the current which is coming from here. The 10 amps is already given, and you can find it out what is the current flowing like this. Okay, here. Okay, so through V you can calculate this current, and after applying the KCL at this node, you can get the this will, what will be the this value? 10 minus whatever the current. Suppose I consider I, so 10 minus I will flow from here, I dash. So you just have to put this value here and you will get the value of R. Okay, getting my point? Any doubt here? You just have to see some observations, means ki how the circuit can be calculated easily. Okay, it will be similar that ki certain reduction will be possible, certain things will be possible. Okay, so you just have to do certain observation and make sure that ki it should the circuit should get reduced. Okay, any doubt in this?
Sir, please explain again near the 10 ampere source.
Okay, so here when you see here, the current is already given here at the 10 amps. Okay, if we able to find out what is the current coming here, so the current which is going out of this node will be just the summation of these two. How we will find it out? We have already found it out. So this potential is already given 100 volt. If the both potential is given, So you can find out the current which is going out of that branch. So if you are able to find out that current, okay, so you can get the current which is going out of that node. That is, I am considering 10 minus I dash because current is already given 10 amps. Okay, getting my point. So if you are able to find out the current, potential is already given. We have find it out, the 60 is equal to I times of R. So you can get the value of R. Okay.
Yes, sir. Understand.
Okay. So this overall things I have explained, but I have kept the few other problems here also for the practice. You should go through that and solve that, and that will help you to solve the assignment, this assignment 2. And if you face any doubt, we can discuss in the next tutorial session. Okay, that's all from my side. Okay, we will see discuss in the next tutorial session. Okay, thank you.
Sir, where these questions slide available?
Okay, there will be link given where this link is given for joining the this session. There only one folder will be there, or certain link will be there of Excel sheet. I'm actually uploading this all slide in the Google folder, Google Drive, and pasting the link there in the Excel sheet. You can go to the Excel sheet. Their link will be there on the NPTEL portal itself, and you will get the presentation video of this. Whatever I have taught you, I am just recording the session, and you will get the recording of that also. Okay, if you're not able to get that,
Yes,
just
sir.
email that email. There is a query email is already given. You just drop an email. The team will follow up with that. Okay.
Sir, previous week's
Yes,
tutorial
yes,
session
yes,
video
yes. I was
was
not
not
able to join that because there was some my laptop was creating some problem. So I have just recorded the session and uploaded the video and the slide there itself. Okay, in that Excel sheet itself of a first week. Okay, there are the other problems are also there of like basic circuit and I is equal to dq by dt. So I have just made that video. You can go through that, and slide also I have uploaded of the assignment 1. Okay,
Where we can get the videos of
there is
this
link.
particular
Link
test.
is already given in the portal itself. You just scroll it down where the announcement is there, so you can get that link there.
Okay, so now announcement,
In
sorry,
announcement section on
announcement
the
content we
page,
can get.
there it's a swam portal where you are logging, or nptel portal. You can get that link there of the Excel sheet. Okay.
Okay, sir.
Okay.
Understand.
Okay, that's all for today, and we will meet on the next tutorial session. Thank you so much for joining.